Okay, here we go. We got 2010 number one. Assuming you've already read through the question and you're good with it, we've got an experiment where they're putting, um, let's see, garlic oil inside food granules made from corn, and they're putting different concentrations of garlic 0, 2, 10, 25, and 50% in them to see how birds react to it. So, and the question is it's actually I guess, a two-part question. Um, for the experiment, identify the treatments, the experimental units, and the response that will be measured. So the treatments. So what is the treatment that is being imposed on the experimental units? Well, the experimental units are the birds. The treatments, what treatment's being imposed? Well, it's the garlic oil infused food granules. Okay, so the treatment is the garlic infused food granules, and there are actually one, two, three, four, five levels of that. I guess that'd be first one. Second one, the experimental units are the birds. We call them subjects if they're people. These are the European starlings. And the response that will be measured, what exactly are we going to be measuring here? We're going to determine the adverse reaction of the birds to the repellent by measuring the number of food granules consumed. So the response variable is the number of food granules consumed during a 2-hour period. Okay, so you got to be real specific on that. Okay. All right. B says this: after performing the experiment, researchers recorded the data shown below. Construct a graph of the data that could be used to investigate the appropriateness of a linear regression model. When I see appropriateness of linear regression, I'm thinking residual plot. You could also do a scatter plot, because in order to make a residual plot, you got to do a scatter plot for analyzing the results. So let's do a scatter plot and see if it's not linear, then that'll be good enough to say that it's not linear, and we'll go from there. So let's go ahead and do this. Across the bottom, we've got 0%. Now we've got 0, 2%. Now this across the bottom really doesn't need to be to scale. 10%. Although, let me redo this here. I'm losing track of my eraser here. On the bottom, although I think I'm going to make it to scale like this. If I make 0 and 50 here, then 25 would be halfway. This looks like about right. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 25%. And I've got 10%. So that would be half of that. 1, 2, 3, 4, 5 is 12, so we'll call this 10%. And then we'll go with 5 is half of that, so 2 is going to be a little bit below. So we got 2, 10, 25, and 50. And then up the side, we've got from 20 up to 58. So we'll try to do this. This part's really important that we're to scale. Actually, when I said earlier it doesn't matter if it's to scale, it actually does. So I apologize for that. We do want to draw it to scale, so we can, otherwise we could hide the curvature of it. So I'm going to go ahead and do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's not going to quite get me there. But if I skip here and go 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and then 60 would be up here. So at 0 I'm at 58. At 2 I'm at 48. At 10 I'm at 29. Oops. At 25 I'm at 24. And at 50 I'm out here at 20. So definitely not linear. Okay. Do I think a linear regression model is appropriate? So B2, since the scatter plot shows distinct curvature, a linear is not appropriate. Oops, hit my erase button on the pen. Yep, and that's all we need on this one. Yep, there we go.